Experiment number 7, determination of the relative density of a liquid using YouTube. The apparatus required for this practical is a YouTube, 2 half-meter rulers, coconut oil, water, clamp stands, a set square. Right. So let's see how we do this practical. So you can see the diagram, and we are going to set the apparatus as we see in the diagram. And here we are using water and coconut oil. So you have to remember always, you can only compare liquids using this device which do not mix with each other. So only you can compare the immiscible liquids. The liquids which mix with each other, like water and alcohol, it gets mixed with each other. So can you measure it? No, you can't measure, or you can't compare those two liquids using the YouTube. For that, you will have to use the Hairs apparatus. So that is the device that we use to compare the miscible liquids, because we don't keep those two liquids in contact with each other. But in this experiment, we are going to use only the liquids which are immiscible, which do not get mixed with each other. So we set the apparatus like this, and one critical point here is that we are going to pour the liquid with the higher density first. So in this, we know water has a higher density than coconut oil, so we have to pour water first into the YouTube before pouring coconut oil. Why? So what will happen if you do otherwise? If you put coconut oil first, and then if you pour water into this, water is high dense than coconut oil. So what will happen is, when you pour water while the coconut oil is inside, the water will go to the bottom, will get stored in the bottom, and the coconut oil will rise from the two columns in the YouTube. So on both sides of the columns, both stems of the YouTube, you can see coconut oil is rising up. So in both sides you have coconut oil, so you can't do the experiment. But you need to have coconut oil on one side. So what you do, or what you need to do, is that you need to pour the liquid which has the high density first, then the liquid which has the low density. So you are going to pour water into this first, then to the right hand side you are going to pour coconut oil into this. Right. So we can see now we have an interface made. Now this is the water and coconut oil interface. Right. So here what we do is that we are going to equate pressures. So you can equate pressure at any level below this interface, not above this interface. You can take either on this level, or you can take either 2 points which are below this level. So the concept here is that you are equating pressures here at the same level of the same liquid. You can do that. You can equate pressures at the same level of the same liquid. You can't equate pressures at the same level of two different liquids. So where do you get the same liquid at the same level first? Is at this point. So the best 2 points to avoid unnecessary calculation is to use these 2 points. So we are equating pressures in these 2 points. So on one side you get the atmospheric pressure plus HW rho WG, which is the pressure created by water, and on the other side you get atmospheric pressure plus HL plus HL rho LG, which is the pressure or hydrostatic pressure created by the coconut oil. So P naught gets cancelled in this, so you can find the value, or you can just equate. Now in these experiments we are drawing graphs. So here also we are drawing a graph. We don't just get the value just using one time experiment. We are going to do the experiment for 5 times. So if you are going to draw a graph, you need to at least do this for 6th, instances because we need at least 6 points when you are drawing a graph. So we are going to make the equation in a way that you get a y equals mx type of a graph. So here you can see it's a y equals mx type of a graph. So which is the dependent variable and independent variable? So x is the independent variable here, which is not going to change depending on anything else that we are going to change it. So y is the dependent variable. So dependent variable will be y and independent variable will be x. So we take hw as the dependent variable, which will depend on hl. So what we are going to change here is hl, and accordingly hw will change. So here, in order to get different ratings, you need to add coconut oil to this, not water. So someone might ask, what if that we add water into this? Why would the HW increase if we add water into this? So here what we take as HW is the height of the water above the common interface. If you add more water to this, HL won't change. So instead the interface will rise and HW will also not change. Right? So the interface will rise. So HW and HL will be constant if you add more water into this. So you should add coconut oil into this in order to get different readings. So you are adding coconut oil. So you add coconut oil, so you change HL, and accordingly you can measure HW value as well. So why do we need a set square in this? You might wonder that what is the reason that we need to use a set square. So you can keep your set square. You can keep your set square like this on this meter ruler, and you can slide it up and down. You can slide your set square up and down on this half meter ruler to exactly find the level of the liquid. You're going to slide it up and down, so you can exactly find like this. So you go to this position, you get a reading, you slide it to this position and you get a reading. So you exactly find the value, the height values, without making an error. That is why we need a set square in this experiment. Right. Once you get sufficient number of readings, you're going to mark it on your graph, and then you're going to draw the line of best fit. Right? We call it the line of best fit. So when you draw the line of best fit, you can get the gradient of that m value. So the gradient will give the relative density of the coconut oil. So that is how we find the relative density of coconut oil using this experiment.